Alright, the power of data, visualizing insight through descriptive statistics, and exploration of graphical representation. Alright, my name is Elisha Olabisi and I'm welcoming you to this module. Actually, this is supposed to be a course with respect to the use of SPSS in drawing graphs and drawing charts. But I will not only be teaching us how we can do all this with SPSS. This is the typical SPSS interface. This is the typical SPSS interface. I will not only be enlightening us with respect to the use of SPSS in visualizing data. I will also be explaining how you can use Microsoft Excel to visualize data. And the reason being that I do not like how SPSS visualizes data. I'm not a fan of it. The charts are not beautiful. SPSS is good with several other things, but when it comes to creating charts, the charts are just off. They are not beautiful. So at least to a bare minimum, I'm not saying that Excel charts are much better, but SPSS is really worse. Alright, so let's explore our slide further. Alright, so now graphs and charts provide a visual way to summarize data, revealing patterns, relationships, and trend. And the first one I want to talk about is the histogram. And the histogram is actually a form of bar graph which shows frequency distribution of a continuous data set. We have categorical data, then we have continuous data or discrete data. So some are in categories while some are continuous, like you can have 1, 2, 3, 4, 50, 60, and whereas you can have some in categories that you have gender, that's categorical. You can have gender, which is maybe male and female, and the frequency of male can be 50, the frequency of female can be 60. Then you can have continuous data where you just have age of people. Age, for instance, is a continuous data set that you have age of an individual can be 50, another person can be 60. Of course, there are instances where you can actually put age into categories, and that's one thing that we do. Like you can actually convert age to categories, but age primarily is a continuous data. So just like your body mass index as well is a continuous data. So that is just it. So, and for the histogram, it's used for continuous data set, whereas the bar chart, on the other hand, you can use it for categorical data set. Whereas, like for instance, you might want to present let's say source of earth information. You want to present data with respect to where people heard about a particular health condition, like where did you first of all heard about the COVID-19 vaccine. That kind of data is best presented using a bar graph, like a bar chart. Yes, it's best presented using a bar chart because that way it's categorical and you can present it. So you can, in your bar graph, your bar chart, you can present it by saying, 50 actually got to know about the COVID-19 vaccine through the healthcare workers. 60% actually got to know about the COVID-19 through lectures, through radio, through televisions. So things like that, that's how you present it. So bar graph on the other hand will be for categorical data, basically, essentially, whereas the histogram on the other hand will be for continuous data set. So now in histogram, you always have something they call class intervals or boundaries. That is, you can have because histogram is for continuous data set. Let's say you have age. Now in your age, your x-axis is going to be for intervals. That is, it's going to be for the class boundary. You can have 0 to 10, 11 to 20, 21 to 30. So 0 to 10, the frequency might be 50, like how many people fall into the category of 0 to 10. That's just the purpose of the class interval. So you want to say how many people fall into the category, and I'm going to show us when we're creating the graph. Don't have any bias man that's going to be difficult. You might want to see that, oh, how many people fall into the category of 0 to 10 years old. From, I told you that it's for continuous data set. Now you have your age. You have your age 50, 20, 10, 0, 1, 2, 3, 4. You have your age like that. Now we want to determine how many people fall into 0 to 10 years old, how many people fall into 11 to 20 years old, how many people fall into 21 to 30 years old, how many people fall into 40 to 50 years old, how many people fall into 51 to 60 years old. So that is just one thing about the histogram, and you represent that interval through the x-axis. The x-axis is the horizontal axis, while the y-axis is the vertical axis. So y-axis most times will show the frequency, just like the bar chart. Y-axis shows the frequency or count. And one thing, unique thing about the bar chart is that they touch each other. And to show that the data is continuous. Yeah, bar charts actually touch each other to show that the data is continuous. Yes, and the height of each bar indicates how many data point falls to that specific range. It shows the frequency. All right, so let's just try out an example using the Microsoft Excel. Then maybe we can do it using the SPSS as well. All right, so we have histogram. Then this is a continuous data set. So let's do something to this. So we can, the first thing I want us to know is when you're working with bar chart, when you're working with histogram, is you need to define the upper limit. That is, in your interval, for example, look at the highest and the lowest value in this data set. Let's say, for instance, what we want to present here is the patient's age. Now let's look at this critically. What's the highest value and what's the lowest value? You can see 19. All right, so now we have 19. Yes, so now let's define our upper limit. So now somebody out there can say, oh, he wants to define the upper limit using intervals of 10. Another person might say you use interval of 20. Another person might say they want to use interval of 30. So in this case, we can actually use interval of 10. But the problem is that we might not find many people falling into certain category, into certain boundary, because you can't really see somebody that is less than 10 years old here. So it's best if we just use interval of 20. If you just use 20, so I think that one will work. So let's just say 20. So when we type 20, what we are implying is that we're saying the interval we are choosing is 0 to 20. That's what we're saying. Now the next one will be 40. So that's 20 to 40. That's 20 to 40. The next one, that's going to be 40 to 60. And the next one is going to be 60 to 80. And the next one is going to be 80 to 100. All right. So this is just what we're actually saying, that the interval is within this range. So this is what we're saying by saying this. So now we want to determine how many people fall into 0 to 20 years old. So if you check this chart, is one person. How many people fall into 20 to 40? How many people fall into 40 to 60? Actually, this is just you can actually draw the histogram without you doing all of these things. This Excel is going to automatically determine the interval it wants to use. And Excel can actually do that. It can determine the interval it wants to use. Just highlight it. Copy your variable. It's for continuous data set. So copy, let's say you have your age, then just highlight everything. You can just select everything. This is for continuous variable. Just select everything. Then come to insert. Then come to chart. You can come to chart. Then let's go to let's look for histogram. Histogram should be around here, or let's just open everything. All right, he's already suggesting which one to use. Let's just go to the one we personally want to use. So we can click on histogram. Let's just click on OK. Now, histogram by itself has determined its own boundary. You can see the boundary that histogram is using here is the first interval it used 19 to 45. Then the second interval it used 45 to 71. Then the third one it used 71 to 97. So histogram by its own discretion actually chose a class interval for itself. And like there are instances that you would really not want to use all of that, and you can edit anything you want to. You can add title, you can add data label, that is, you can see all these label. So that's the frequency, number of people that fall within this age, number of people that fall within this age bracket, number of people that fall within this age bracket. You can add anything you want to add to it. Yes, you can add anything you want to add to it. You can bring it, so you can click on this and do all that. You can change the styles. You can change the styles. You can change anything, the color. You can change the style. You can change the color just by coming here. Yes, I always love when you're dealing with some things that you just use certain color, and I'm going to explain when we get there. All right, so that's just it. So histogram by its default state has drawn the chart by itself. I want you to do something when you're doing this course. Try as much as possible to post results on LinkedIn. Tag Pestat Consulting. Tag myself, Elisha Olabisi. So post your result on LinkedIn. You can organize it. Put one here, put one here, put one here, and do a screenshot. The way to do a screenshot: look at FN on your system keyboard, and then look at PRTSC, print screen. Like just click on those two keys at the same time, and you will take a good screenshot. Alright, so just like SPSS, Microsoft Excel can actually perform data analysis, like even more than SPSS, but SPSS is easier to use, like for our research purpose. Alright, so now the way to do it is to first of all go to File. When you go to File, then you select Options. You select Options, go to Options. Then when you go to Options, then you look out for add-ins. Excel has a data analysis tool pack. So click on this add-in. You need to manually do it. Click on this analysis tool pack, then click on OK. By default, when you click on that, by default you will see the data analysis. Just click on Home. Let's click on Data again. We are waiting for the add-in to load, and you will see the data analysis aspect pop up just by default. So while we wait for that to happen, we can actually edit this chart manually. Just click on, we want to define our own boundary. We want to define our class boundary. Let's just click on this. Click on this. You can right click, then click on Format Axis. Click on Format Axis. By the time you, so I left click on this. I try to select only this axis, not the entire chart. Format Axis. So now doing that, you see the one that was selected previously was automatically done. So now we want to determine the class interval that we want to use for the age. So we can say, oh, we want the interval to be 2020, like we want the interval to be 20, and you will see it as 20. So we can define that and just click on, and just let's see it. So now we have defined the interval to be 20. So we see 19 here and 39. So from here we can see that, let me add some things. Let's add some element to it. We want to see the data label. All right, so now we see that 6 people fell into this category, 6 into this, 6 into this, and 2 into this category. All right, so now we can as well still format it further, just clicking on this axis again, left clicking on it, then right click, then format axis. Now when we click on this format axis, we can determine the number of bin. We can say, oh, we want it to be 5 category or even 6 categories. Of course, some frequency will be 0, so we want it to be 6 categories, like 6 classes, like you divide it into 6. So you can see we already have it. So this is histogram. You see there are no space in between, like they are not substantial, there are no space, unlike the bar chart. So that's one thing with bar graph. Yes. So unlike these, that's one thing with the histogram, unlike the bar chart. All right, so let's move to the next. Let's make progress. The data analysis is not coming up, probably due to the internet. Yes, but the Excel has the data analysis 2-pack. Like this would only be majorly due to the network. All right, just the adding, then just select this analysis 2-pack. Oh, I did not click go, sorry. So just click on go, then analysis 2-pack, then we'll click on OK. Yes, so this is the analysis 2-pack. So we can always select it. And by selecting it, we can calculate. You see, we can calculate ANOVA, correlation, covariance, descriptive statistics. You can histogram, draw your histogram, all those things. You can do a lot of that: analysis, regression, t-test, sampling, z-test. You can do all of this just by enabling the analysis 2-pack. So we did not click on the go icon or button. That was why. So file, options, and adding, then go. All right, so that's just it. Okay, so it has an analysis 2-pack. You can explore it, and in subsequent time I might explain it, but this is the purpose of this course. So let's move to the next. So we can do the same thing for this. Is just for the chart title is the age of the participant, and when you're drawing graph, you can always remove this chart title, though the latest APA style suggests that chart title can still be on top. I've not verified that, but as far as I know, it's best. So you can edit your chart title. You can remove this chart title and just manually enter the text downward and say figure 1, bar chart or histogram showing the age of the participant. So you can edit, you can delete this, and when you're copying it to Microsoft Word, you can just copy your chart to Microsoft Word or PowerPoint or wherever and just write underneath figure 1, histogram showing the age of the distribution. All right, so we can do the same thing for the waiting time as well. Just select it, like the waiting time of maybe some patient who came to the hospital. So you can calculate that still using the same approach. Just click on the histogram, insert, then come to chart, then click on all charts, then click on histogram, and there you go. Just click on it and you have it already. So you can see this, the waiting time. So you see that the waiting time is always between 10 and 29. Is it in minutes? Yes, waiting time in minutes. When patients come to see the doctor, the nurses, the time it takes for them to get attended to normally last within 10 to 29 minutes. Like mostly, you can see it has the highest frequency, then followed by 29 to 48 minutes. So that's just one thing with the histogram. All right, so there are other charts and they all follow similar principle. When you understand one, it becomes so easy to do the other. Yes, that is histogram for continuous data set. Now we have bar chart, which is for category. So first of all, you need to define the frequency of your categories. Now, the disease type now, for instance, the category we have malaria, we have typhoid, we have cholera. Now, how many people had malaria? 150. How many people had typhoid? 80. Unlike the histogram that is just age, we have 60, 70, 80, that kind of thing. And then you determine how you want to group those age brackets. Those age. You determine how you want to group the age of the participant. Now, for bar chart, you have malaria, you have typhoid, you have cholera, you have tuberculosis, you have all these categories. Now, you've calculated, 150 people had malaria, 80 people had typhoid, 30 people had cholera, 60 people had tuberculosis. Now, just select the two. This is the disease type, this is the number of cases. You can make a request for this Excel spreadsheet, and I'm going to send it to you so that you can use it as well. You can practice on it. When you even have needs, maybe you want to create a chart for your project, you can actually edit all of this. For your instance, now your own case might be source of earth information frequency, so you can edit it like source of earth information frequency, or just click on, let this one be the source of the one here, let it just be the number of cases, or let's just say disease type, so that's what it's going to bring. Or whichever way, you can always edit it. So just click on this, highlight everything. That's how to draw the bar chart. And let's just look at our slide and see one or two things about the bar chart. So similar to histogram, the bar chart uses bars to represent different categories or groups. It is often used for categorical data, which each bar corresponding to a category and the height representing the frequency of the count. So the height is representing the frequency of the count, while the bar is representing the categories, the various categories that we have. All right, so now let's go to the Excel spreadsheet again, and then let's draw some chart. So insert, you can have this, you can click on several other charts. There are several charts, and click on these, and now we have all of this. So there are instances that you might have multiple charts, whereby different charts will mean different colors. You can have that as well. So now you can see our chart. So this is our chart already. So that is just one thing about the bar chart. There are other charts, but at the start, this is going to work for you at the start. Of course, as going further, you really need to learn some things, because there are instances whereby you're drawing a chart and you're comparing different categories, but this is one thing about it. So you can, another thing, let's do another one. Let's draw another chart. And you can always select your options. Like you can go to chart design, you can select the type that you want. If you want the number to appear on it, just click on this. First of all, you can click on the one with number, then just click on the one that you want. Then you can always edit this. You can edit it, maybe 150. I want to edit it as 150. Maybe I want it to be percentage. Like I want to edit it and just use maybe 150. So how many people in 150? Maybe 40%. So I can edit it. You can always edit it. And rather than using the actual frequency, you can import the percentage from SPSS and use it as well. So that's just one thing about the bar chart. So you can, just like this, you can edit the things that you want to edit just by clicking on it. You can edit anything you want to edit, format data label, change data label shape. You can edit as much as anything you want to edit. You can edit it, you can format just by that. And then there's another function here, add quick layout. You can do that. You see, you can put this there. You can put this there. Then at the same time, you can have all of this You can add, you can edit just using all these quick layouts. Then you can add chart elements. Anything you want to add, you can add it. Yes, using that. So that is just one thing about bar charts. So let's draw more bar charts as well. Like, so this is hospital department, then the number of admission. Let's just select this. Then you click on bar chart, and this is it. And here you have the bar chart. You can always edit the title. So you can select other formats. You can select then there are other charts as well. Let's just click on chart, bar chart. Then, or let's click on, better still, let's delete this. Let's delete this and let's click on insert. Then we want to select other forms, other chart type. Yes, for all chart, just click on all charts. We have the column. Yeah, that's like the bar charts most times. Yes, so we can just select the one that you want. Select the one that you want, and you can now come here. This one is good, especially when you're doing some real-time comparison and you want to check the magnitude of some maybe disease cause condition across certain year, maybe disease condition in 2020, the burden of the disease in 2020, the burden of the disease in 2021, and you want to present it. You can use this. This is also bar chart. This is bar chart. This column as well is bar chart. All right. So that's just one thing. And you can use another approach whereby you use numbers, where you use color and determine what each color means. Actually, you can do that. Though you will need to determine what each color means, represent actually. Yes. So that's just the drawback to that. All right. Let's remove this. I click on it and I deleted it. So you can see this. So you might want to use this. Let's just use it this way. Click on this and delete this number that's showing. All right. So you can see this beautifully as well. So there are several other charts you can draw that way. So now this color now has shown us what each bars represent. Now in this case, you can go to chart layout. You can determine how you want the color to show. Just come to legend here. Then you want this thing to be at the right. You want everything to be at the right like this. So do all of these things, put it on your LinkedIn, show us, put it on your LinkedIn, and let us see what you're doing. Like, so there are other data sets. I have another example: routes of drug administration and the average time of placenta. So we want to see which route of administration actually aided placenta separation, or let's say placenta expulsion, like that reduced the time. So we have the intraumbilical vein, we have the IV infusion oxytocin, have the IM oxytocin. So which one actually performed excellently? We see that the time for intraumbilical vein was lesser compared to the infusion compared to the IM. So you can see the time of separation of placenta was lesser for the intraumbilical. So we might want to present this using bar charts. We might want to present this using bar charts, and we just click on this, then you click on this, then you can click on this. Then I will just say, like, let's just click on it this way. Then all charts, then all charts. Under this you see this option, and then you see this option. So you can click on this, then click on OK. Personally, I love this chart compared to this other one, because this one looks more appealing. Like, I'm a big fan of when something is fine. I love it. All right, so you can just select this and add chart elements. Personally, I would prefer this chart. Then I can click on add chart elements. Then the label, no, I want them outside. All right, then you can edit it. You can use anything that you want to use. Then I want the legend to be by the right, this way. Yes, so I can reduce this. Actually, I can reduce this, and let me just increase it here, so that I can easily conveniently reduce it. And then I can give room to my chart, for my chart. So this is it. So now I can delete this average time of placenta separation if I don't want it to be there, except if I will need to, if there is a way, except maybe from the point of selecting, you would have put it there that figure 1 average time of placenta separation in minutes, except if you will do that, like why typing it. Yes, except if you do that. Okay, so left to me, I can just delete it and then write it underneath figure 1 average time of placenta separation. So that's just it, because it's important to label it very well. So that's just it. So do all of these things and let's see what you're doing. If you have issues, definitely you shouldn't really have issues for real, except if your Microsoft Word has, your Excel has issues majorly. But if there are issues, you can reach out to us. We'll guide you. All right. Okay, so now we have other chart types. Let me go to, okay, that's for the bar chart. Then we have the line chart or graph. A line chart displays data points connected. Let's go to the pie chart. Let's follow the progression in the Excel spreadsheet. You can do all of these things using the SPSS, but you will not like it. I don't like it personally, but I'm still going to show you so that it won't look like, oh, you said this course is about SPSS. Is it that you don't want to teach us or you don't know it? No, I know it. I know how to use all these tools. I know how to do Power BI and several others, but Excel is good. It's very, very good. Yes. So now let's go to pie chart. A pie chart is a circular graph divided into slices, with each slice representing a proportion of the whole. That is, for instance, you want to see how different diseases contribute to maternal mortality, and you want to see the different factors. You want to see the weight of those different factors in contributing to maternal mortality. So pie chart can actually show you that it is suitable for displaying part of a whole or percentages. That's one thing with the pie chart. All right, so now let's go to our charts. Now, like, you want to see how many people had, like, maybe positive and negative attitude there. Me personally, I prefer using the pie chart when I have just 2 categories. Actually, of course, it works for others, but it's just a personal preference. So now this is it. Click on this, select. So now you have your categories here: positive, negative. All of these are templates. If you join our class, and with time, I'm going to be dropping more templates. All these are templates, and when you want to plot graph for your project, just use this template, and that's it. Just use this template, just edit it. Your good knowledge can be here, poor knowledge can be here. Maybe you have fair knowledge, good, fair, poor, and that's it. You're good. And then you can edit the color, because most times when I'm dealing with maybe poor knowledge, I want poor to be a color like red, while I want good to have a color like blue or green. Then I will have fair to have a color like maybe yellow or any other color. But I wouldn't want good knowledge to have a color of red or orange. So that's just one thing I do. Like, I'm always conscious about the color trend. So now just select it. That's all. Don't select the total. Select it this way. Then click on this. Then click on insert. Go to chart. Just click on this thing so that we'll see the chart. We're selecting. Click on all charts. Then go to pie. A pie chart. We have pie, and we select our pie. Now, there are different type of pie charts that you can use. You can use this 3D. You can use this one that will show the stuff, the count and everything. Then you can use the donuts. I love the donuts actually. Donuts is actually very good, especially when you're dealing with population analysis. Donuts is very good. It looks so beautiful. Yes, this is our pie chart. Yeah, just click on OK, and you have your pie chart. So now we can do something. I always want this positive and negative to be by the right side. though it's okay this way, and I don't like the title being here. Yes, though there is like saying that the upper style says that the title should be here, but I love the title being underneath, and that's what most supervisors, most institutions will say, that the title should be underneath. Yes. So now let's go to chart elements. We can chart label. Okay, I want to have the chart label in between center. You can see it a 50, 70. Good. And you can actually determine, let's use percentage as our chart element instead, or better still, we want to see both the percentage and both, we want to see both the percentage and both the count. So you can select this option. So we can do that, and you can always edit it. 50, put bracket, 41, you can edit it. So just try to double click on it and edit it. You can edit it manually. So just go to chart element, legend. Oh my god, right, I love it when it's at the right side like this. All right, so let's put this on one side. So now fully vaccinated, all that. Now let's do this too. Insert. Now this time let's use donuts. I love the donuts instead of just the regular bar chart. Right click, all chart, all chart. Yes, then let's use the donut pie, and let's use the donut. I love the donut. So that's just it. So this is one thing with the donut. So now you have different styles. You can click on this, you can click on this, and then come and click on this. When you do that, this percentage, you know, initially the percentage was not showing. So when you click on the one that has percentage and you go to another one that doesn't have percentage, the percentage is going to show. I click on this as well. There are several styles that you can use. I love the donuts, especially for population statistics, population analysis. I love the donut. Yeah. So that's one thing with the donut. All right. So let's make progress. So you can do that for the same other ones. And I want you to do all of these things, analyze, do all these things. Then we want to see how different diseases contribute to the burden of morbidities in the hospital. So we can just select this. These are the diseases, that the categories. Select it, insert the chart, insert, click on this, then go to all chart. Then we don't want to use this bar chart. Bar chart is good to present something like this as well, but let's just use a pie chart because this is what we're learning. So you can see, you can select this. It's already showing you how different diseases contribute to the morbidity of the facility. All right, the burden of illnesses in the facility. So we can click on the donut as well. You can click on the donut as well. We can click on donut as well, and we are good to go. So you can bring all these things to the side so that you save space. So chart elements, we can do all of that and bring it to the right hand side. So you can see it's looking nice this way. It's looking nice this way. All right. So that's just it about the pie chart. Oh my god. So next thing, let's go to this scatter plot. Let's check our PowerPoint. What we have about the chart, scattered plots. Okay, let's go to the scatter plot first of all. A scatter plot displays individual data points on a two-dimensional graph. It's important to note that scatter plot is useful for visualizing relationship between two variables. Now, scatter plot is very good. For instance, you conduct an experiment. You want to test a drug, and with respect to the time of recovery, maybe like an anesthetic agent, which you want to test how effective that drug is with respect to the time people recover from the anesthetic agent. So you want to see the relationship between time, like you see the time and the time of recovery from the anesthetic agent, like we want to test it, and the dosage of the drug. That is, at 5 dosage, what was the time of recovery from the anesthetic agent? At 10 dosage, what was the time of recovery from the anesthetic agent. So now you want to visualize relationship. Now there are some graphs that you will have a positive linear relationship, that is, as one is going higher, as the time is increasing, as the dosage is increasing, the time of recovery from the anesthetic agent is also reducing. As the dosage is increasing, the time of recovery from the anesthetic agent is reducing. While some, as one is increasing, the other one is increasing. That kind of chart will follow this kind of, it will go up like this, like as one is increasing, the other is increasing. Whereas the chart that as one is increasing, the other one is decreasing, in an inverse relationship, is going to come down like this. And whereas as one is increasing, the other as, or probably a graph that doesn't have any association, that is, they are just like there is no clear trend. So that kind of chart will have something like that will look like horizontal. So let's go to the scatter plot and let's see the examples we have. Scatter plot examples we have. So this is just about the data visualization. Yes, we go to this. This is age and blood pressure. Now let's see the association between age and blood pressure. Like normally as people's age increases, the peripheral resistance, all those things. So the blood pressure, blood vessels become thickened, and the blood pressure actually increases. Now let's see the trend. So I've selected it already. Let's go to insert, and let's click on this. Then you can see it's already showing that scatter plots will be the best to present this data set. Though it's already suggesting other data chart type, but I tell you, trust me, it's scatter plot that is the best. Let's just go to it manually. We have the scatter. Where is it? X and Y. Yes. So this is just one thing about it. Now we have types. This one is just showing individual data points. Yes, which this is not how we want to present it, because we are comparing X and Y, like we are comparing the two. So this is what you choose. This is what you choose. There are instances that you use this. There are really instances that you use this. But for now, use this. Sorry, click on this. So we can click on OK. All right. So you can see what I was saying, that as this one is increasing, as age is increasing like this, the blood pressure too gets increasing. So now you can format this and let us show this trend perfectly. You can add legend, you can add title. What do you want to be here? Like, okay, this is the age, this is the blood pressure in millimeter of mercury. So you can edit this template that I have, because this is what is on the first one will be on the x-axis, that's the age. Most times the independent variable will be on the x-axis, while the dependent variable will be on the y-axis, that's our blood pressure. The dependent is the one that is being affected by the dependent. Age is affecting blood pressure. All right. So now we want error bar. No, we don't want error bar to show. We want data label. No, we don't want data label. Then we want legend. No, we don't want legend now. But we want trend line to show. So now we don't want this type of trend line. So we are still going to change it. Okay, it's linear trend line. At times you can have all these exponential and others. So just click it, just let it be. So now you can click this thing, this trend line. I want to format this trend line. Just click on this trend line. Just click on this trend line. I want a different trend line. I don't want broken lines. You can see I've selected another style of trend line. So you're good. So you can see now that you've shown the trend, linear association between age. You can edit this and write the blood pressure is in millimeter of mercury. This is our blood pressure. And these are still the blood pressure, and these are our age in years. So you see a clear linear trend. So that's one thing with that. That's a scatter plot. So as one is increasing, the other is increasing as well. That's scatter plot. You can do that for hours of exercise, and cholesterol level. When people get engaged in exercise, there's a way it reduces the cholesterol level. That's also going to show a clear linear trend, upward trend. That's just one thing. So let's go to let's go to the line chart. People mistaking line chart with the scatter plot at times. They mistake the line chart with the scatter plot as well at times. Yeah, they do that a lot. Yes, because they would think that because this is line, it is showing trend. Line chart can as well show trend, but the issue with line chart is that line chart is just for one. Like, instead of having age and systolic blood pressure together like this, you just have systolic blood pressure, and you want to see the way the kind of trend of systolic blood pressure as it's increasing. Do you get? So at age 1, like for case 1, what was the systolic blood pressure? For case 2, what was the systolic blood pressure? So line chart is just going to show us, like, let's just say, for instance, let's select this. Line chart is just going to show us trend. Then line chart, so 2D line, you can see. So line chart showed us that, okay, for the first patient, this is the, let's say, each time point, like this number represents maybe the cholesterol level taken at different time interval. So this one is 1, the first reading read this, the second reading read this, the third reading read this, the fourth reading read this, the fourth reading read this, the fifth reading read this, the fifth reading read this, the fourth, sixth, seventh, eighth. So that's just one thing with the line chart. So you can see this chart now that is irregular, kind of like, let's say it's pulse rate. Now you say, oh, the person has irregular pulse rate, that kind of thing. That's one thing with, like, it's just good for minute things like that. You have the person has irregular heartbeat. That's one thing with the line chart. But even at that, you can actually plot it. Let's say you have well-defined time that you're checking. You can just put your time here, and then you put 5, 10, 15, 20 pulse rate, and then you put pulse rate here, and use the scatter plot. Scatter plot is going to show the trend of the pulse rate with respect to time. So it's going to show the relationship, like, with respect to time. It's going to show the trend also. But you can still use this line chart as well. Yeah, so each number will represent each point of measurement. At each point of measurement, these are the things that we got. Yeah, so that's one thing with the line chart as well. So line chart is good for trend, So let's just see, a line chart display data point collected by lines, often used to show trend or changes over time. The x-axis typically represents time or a continuous variable. You see, represent time or a continuous variable. While the y-axis represents a variable being measured. So that's one thing with the line chart as well. Then we talk about the scatter plots. So always label very well. You see, label this. Then another example, bar chart. You see, key. You can add this thing to it in Microsoft Word. In Microsoft Word, I just go to insert. Then you see shapes. You see shapes around here. You see shapes. Then you can type it and put this key on top of it. Then you can edit this. Like, you can always edit this. Alright, in anywhere. So figure, see pie chart showing. So that's just one thing with it. And the interpretation present the overall level of knowledge. More than half had good knowledge of ETI. See, when you're presenting data reporting, just report half of it. Don't report everything. They can see it in the chart by themselves. Just report the significant one. That's just it. So this is scatter plot. But if it is a line chart, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. So this is line chart as well. This is a line chart as well. This is a line chart. Yes. So one thing, because you can see the oh no. You can see 1, 2, 3, 4, 5, 7, 8, 9, 10, showing both the time and the pulse rate as well. So you can see the time moving, this time moving, and you see the pulse rate just coming down like this. Scatter plots, I've already talked about this. I've already explained all of this thing, really. I mean, thank God this slide is visible. Anybody can just read it to get more information. And this scatter plot as well. And I've shown you how you can draw the line, how you can draw the trend line so that it will show the trend. Now, we are getting close to the end, and I'm going to still show us some things. I'm going to show us how you can do some of these things using SPSS, but very briefly. I will rush it, but you still get it. Yes, and we are always open to this course is a mentorship course. Like, we are open to explain these things to us for you. That's why it's mentorship. That's why I didn't just record video and just send them to you and just leave everybody. We'll look at it together. All right, we'll learn together, we'll grow together. Box plots. Now, box plot is also referred to as box and Wixar plots, are utilized in descriptive statistics to visually represent the distribution of numerical data. Box plots is really the most detailed one, actually, like the most detailed kind of representation that you can do, data representation that you can do. And this is how the box plot looks like. Now, you will have the median in the middle. This is how the box plot looks like. The median is in the middle. The 25th percentile. What do you know by the 25th percentile? That's the first quarter, Q1. What do you mean by percentile? That is, divide a distribution. Let's say you have a class of 200. Divide the 200 into 100 parts. That means each part we have 2. So now the 25th percentile, that is like the 25th percent, like the percentile when you divide it to 100. So now that is the Q1. The 50th percentile is the median. Then you divide it into 100 equal parts. Then the 50th percentile is the median. This 75th percentile is the Q1, is the Q3 rather. The median, this 50th percentile is the Q2. All right. So Q means quarter, like quarter, from the word quarter. That's why you have 25th. That's why you have 50 and you have 75th quarter of 100%. Then this is the minimum value and this is the maximum value. This one will show you, see the outlier. Like the outlier simply means extreme value. That's, let's say you have age. In your age, the normal age 1, 2, 3, 4, 5, 6, 7, you now have 100 years old among you. That 100 years old is an outlier. And that's why you see some people say school is a scam. And they will make reference to Elon Musk, make reference to Bill Gates or some people like that. And that is an outlier because majority of people with school or successful people are educated. Very few that are not educated are successful compared to, so that those examples are outliers. So now maximum whisker head outliers. So that's just it. So we have the minimum here, we have the maximum here. So you can see that this thing is really, really more detailed. Like very detailed. That's one thing with the box plot for you. Very, very detailed. So now let's show you. Let me show you how you can do it in Excel. Box plot. Okay. And I think we are good here. And this is like second to the last. Or I will just show us one or two things. Okay, let's do this. Treatment group. Box plot is so good. Like, I mean, I love it. We have the treatment A. Now, this is like an experimental study outcome. Now, treatment A, the people in treatment group A, they receive a particular intervention. Maybe some people receive diversional therapy. Maybe some people receive pharmacotherapy. Maybe some people receive massage. Maybe some physiological approach like massage or all those things like that. So now you have different study group and you want to assess their pain level. Now, this is the outcome, their pain severity. Now, we want to compare them together. Do we have more group? Oh no. I would have loved if we have more groups. I would have really loved if we have more groups, but nothing spoils. So just click on insert, come to this, then click on all, and let's click on box and whisker. All right. The beautiful thing about this thing is that it has grouped it for us. We didn't have to say, oh, treatment A, this is it. This is how you present it. This is how you present it. It will group it, determine the highest and lowest, all those things like that. So this is it. It has shown us everything that we need to have. The extreme values, the outliers, the percentile, those things that shown us everything that we need to have. So this is it for us. So you see the treatment A and treatment B. So this box plot, I actually love it. You can edit it. You can choose the type that you want. You can add chart elements. You can add anything, maybe legend, anything. You can add anything you want to add. You can do all of that. You see, it's already showing the data. The 5, 2. So here, 5 is the highest pay level, 2 is the least in this group. And then we have the 4, we have 3, that's 25th percentile and the 75th percentile. So that's just it about that, the box plots. So when you have groups like that and you want to present a detailed findings about them, you can always use a box plot, so that in instances like this, and that's why I give us this example, so that you can look out for relevant examples if need be. So we can do this as well for vaccine uptake, just to have a clearer, detailed view. Vaccine uptake in percentage vaccine uptake in various geopolitical zones. We just want to see, we want to use the box plot to present them and see the range. Like, we collected data from different area, from area 1, area 2, area 3. We want to see the vaccine uptake and want to present all of them. All right, this one has already, a clustered column has already presented everything for us. So this like sum, this one use sum of vaccine uptake. This is like a clustered column chart. It uses the sum of it. But if we want to do it, we are not going to use the sum, because this percentage, we cannot just add all the percentage together. It won't make sense. We'd rather find the average. So instead of sum of vaccine uptake, we just use average. So let's just click on all chart. This is not where we're going to. Oh no, we are not using that. We are using box and Wixar. Now click on this. You can see this. So now you can see the way it is. Do you get? So now you have the details about each. This one, this is the highest, this is the lowest, this is the highest, this is the lowest, this is the highest. So let's say you conducted studies across 4 areas in southwestern Nigeria. You can use the box plot to present them, and you have the north central, northeast, northwest, southeast, south, and southwest. So that's just one thing with the box plot. Then the next thing, I think the map. Actually, map is very important. You can go to mapcharts.net when you want to create some maps for your research. Maybe you want to. So mapcharts help visualize regional differences in. Okay, this is an example of vaccination coverage, but it's visualize regional differences. That's what map charts do, basically. So we have heat maps as well. They use color variations to represent data values. I'm not really going to be delving into this. There are other things to delve into, like when we have maybe advanced class, we can actually explore the heat maps furthermore. Yes, a gradient is used with one end of the spectrum representing low values and the other end representing high values. They are excellent for identifying pattern, clusters, and outliers. And large data set areas with similar colors indicate similar data values. That's one thing with the heat map as well. Like similar colors like this, you represent, so it shows gradation. Actually, yeah, they are used across many fields. So this is an example of heat map. Like the closer the color, the similar color shows that similar values. So now let's go to our Excel and let's draw some charts. I hope I'm recording. All right, let's draw some charts. Let's go to, is it chart type now? No. Okay, let's go to insert. What's happening? Okay, let's go to, I think I have the data set specially for the heat map. All right, now we have, if my network is stable, then we should have something beautiful. So now I want to draw a map. This one is not heat map. This one is normal map chart showing the vaccine percentage uptake rate, COVID-19 vaccine uptake rate across different states in Nigeria. Just select everything like this. Go to map, insert, and then just click on this and watch the magic happen. But if the network is poor, it might have issues. So you can see now. So you can see the trend. The highest vaccine uptake is 65%, while the lowest is 13%. Now you can see the higher the color, the deeper the color, the deeper the level of vaccine uptake. So you can see the deeper ones. This is where the vaccine uptake were much, and you can see that some were so small. The vaccine uptake were small in some places. So you can do it that way. You can draw your charts. You can add elements, anything you want to add, data label. You see, you can add it like that. All of these things, people, you can add more legend. You can do all of that. You can determine how you want it to appear. You can add labels. You click on this label further. You see, you're showing more. You can click on show. You can click on more data label options. You can select that. You can change styles. You see, you can change styles. The color, you can change color. Yeah, you can change color. You can use green. I'll prefer green actually. I prefer green, so that's the place with the higher. Yes, I love that. So that's it, and resonate with the Nigerian flag. All right, so you can see this now. That's just it. So now there are several other charts as well. There's a pivot chart. How do I explain this? One thing that the pivot chart can do is, the way we presented this thing, pivot charts can actually let me show us something here. There is a chart, all these bar charts, like there's a chart that can actually show mean, average, like that can show average of, let's say for example, you have control group, you have group A, you have group B, you have group C, and you want to compare the mean score of these groups. You can easily use a pivot chart to achieve that goal. So now you can click on insert pivot chart to achieve that goal. So now you want to show, now this is me. Let's say this one represents the blood pressure of the people. This is totally blood pressure of hypertensive patients. So some people use, maybe we are comparing different ABA mixture on blood pressure, ABA extract A, ABA extract B, ABA extract C, and then the control group, maybe we selected people with blood pressure very high, like 180 millimeter of mercury, and then the control group receive a particular medication. I want to compare it with the ABA extract ABC. So now maybe the control group receive a particular antihypertensive medication. Now let's do this. Now we want to present the mean score and want to compare the mean score and show it graphically. Yes, you can do that. We will show the mean score and the standard deviation. Standard deviation is similar to mean spread, like how spread the distribution is. For example, you have a class and you have people age 10, 11, 12, 13, 14, 15, 16, 17, 19, 20, 10, 11, 12, and out of 100 people in that class, their range is 10 to 20. The standard deviation will be small. But let's say you have a class of 100 people, and then you have age group like 20, 30, 40, 50, 60, 70, 80, 90, 100. The standard deviation will be wide. So that shows it's for spread. It's for spread. Now just click on this. I'm looking for how to explain it better. Then click on pivot chart. Just click on pivot chart. Yes, so this is it. So let's click on the pivot chart. It has highlighted it for me, so it's easy. I can just new worksheet, or let's just use the existing worksheet. Oh, sorry, let's use a new worksheet. All right, now it's bringing this interface. The next thing you want to do is click on this and click on this. Can you see that? Now what we are comparing is not total, because what this one is showing now is total of this column. It's showing total of, if you check this, you will see that we have control group, we have different people. This is 24 participants. Now we have 24 participants. We have participants 1, 2, 3, 4, 5, You can see that. Then we have this other one to 1 2 3 4 5 1 2 3 4 5. So we have that 1 2 3 4 5 6. Okay, control group, we have 6 people. Okay, we have four groups. That's like 4. So six individuals. So now this pivot chart has already added everything together for us. And adding everything together will not give us a reliable estimate. It's better if we use average. So now what will you do? Just come to this place and click on this. Double click, left click, like double it. Then select average. Average would have been the best to use. Then click OK. So now we have average. It has calculated the average for us. Now, the next thing I want to do is I want to format it. I want to show the standard deviation so that they will know the spread of each blood pressure across each group. So that I want to see the spread, whether the blood pressure is widely, because at times you can have a spread of average alone can be deceiving. A class where you have age 10, 2, and 100. One person is age 2, another person is age 100, another person is age 80 or 50. When you add these three together and you divide it by 3, people will not know that there's somebody that is age 2 in that class because the age will be high. But by the time you calculate the standard deviation is going to show that, oh, this thing is actually widely spread, widely distributed. This is actually widely distributed, like the spread is high. So you know that, okay, the range is actually very high. Using the standard deviation, you see the spread. So now let's click on this plus sign and go to error bars, select it. Now, we don't know what this error bar is because this error bar at times can mean confidence interval. It can mean many things. So we need to specify. We can use standard error of mean, but don't use standard error of mean, use standard deviation. Here we have standard deviation and we are good. I don't want this. I don't like how this total is showing. I don't want it to show. I don't want it to show. I can just delete it, or I edit it in the styles, or sorry, in the legend, and just, yeah, all this data label as its title. If I want to add anything, I can add it. If I want to add any trend line, I can add it. So I can delete it. I don't want it. Yeah, so you can see this now. Very good. Copy your chart and take it to wherever you want to take it to. And that brings us to the end of this class. So if you want to use SPSS, just come to, I have some data sets. You can request for this data set. I have some data set here. Just go to graph. You can go to legacy dialogues and pick out the chart that you want using the same principle. Histogram, let's pick one data. Let's pick maybe day 7. You can see day 7 here now. Just pick on variable. You know, I told this for continuous data set. Click on OK. You can request for SPSS app. We'll send it to you, or just follow the video on how to. Alright, so that's just how you go about the bar chart. I guess a lot of things are open. See, SPSS can be funny. See the way it's delaying. So you see what I was saying. I don't like this graph. It's not fine. So I don't like this graph. It's not fine. Now let's go to another chart type. We can do that pivot chart we created. We can actually create it with the histogram. So just click on graph with SPSS. Just click on graph. So we have the data set here. Just click on graph. Click on this. Then you can click on legacy analogs. Sorry. Then come to, can do a scatter plot to show the relationship between control group and day 1. Can do a scatter plot. You can. It's not fine. That's just it. They are not fine. Simple, but they are fast. Okay, let's say variable 1 and 2 now. Okay, variable 1 will be x-axis. This is variable 1. Maybe time, and then this one may be waiting time. Variable 1 and then variable 2. Y-axis, maybe the waiting time. Then we click on OK. You see, it's not fine. This is it. Variable 1, variable 2, waiting time, then the time. Sorry, or maybe dose and maybe the minutes, time of expulsion of maybe placenta. I copy the data set from, I think, the Excel file, but I'm not sure the particular one. So now this is scatter plot showing relationship between two variables, two continuous variables. Now you see that if you click on this, this is not fine compared to the one I showed you. We can double click on this. When you double click on it like that, we can now edit it. So you can double click on it again, then you can edit it. Now I want line to show, add fit line to it. So now you see we already have the fit line showing there already. So now I don't want this y is equal to that is showing, so I can just, and I can deselect this attach label to the line and apply. Just close and we are good. So we are good. So you can copy this and go and paste it. You can see that it's not really looking good. You just look like graph of 1980 when there are even other tools that draw graph better. The people that subscribe, that will still teach them some other things with time, but that's when we are done with the course. I will teach them how to use some tools that will make them to draw very fine graphs. Alright, so but let's finish the ones that we are on currently. So the same thing with graph. You can click on legacy analog. You can do bar chart. Let's do bar chart for the control group. So you can, like I said, they are not fine. I will not confess. Okay, the group. Let's just, okay, category. This is category, so we are doing the graph for it. You see the bar chart is not fine. So that's why I don't like the SPSS bar chart. But it's good for other things. Legacy too. Come to which one have I not done? I'm not showing you scatter plot, right? Okay, this is the line graph. You can as well do that one too with it too. It's still the same principle. Yes, still the same principle. And for bar chart, you can actually draw the pivot chart using I think using this bar chart actually. So what you just do is select that thing I selected and then click on other statistic mean. That is mean that I want to present, like mean of what we presented the other time. Yes, mean of maybe the blood pressure with respect to their group, like blood pressure, the average of the blood pressure with respect to people in the control group, with respect to the intervention that was delivered to them, the average with respect to the intervention that was delivered to them. So click on mean, click on statistic, sorry, this mean, then let's click on the variable that we want to do that to. Let's click on the variable. So now we have the group, we have the variable, then let's say we have the variable, then we have the group, then we have, let's just use day 1 for instance. So we want to compare the mean for day 0. We want to compare it with respect to the group. That is for day 0, like just like the data set we have here, just like the data set we have here, how that we want to compare it, like the people that were in control group, the people in extract A at day 1 want to see heat, want to see what they have, and we're able to come up with this. That is the average blood pressure for people in control group. This was it. The average blood pressure for people in extract A, this was it. Extract B, extract C. Exactly. So now we can see that extract C was more reduced compared to all others, though the standard deviation is too wide. So that's just it. Now let's come to here now, like mean for day 0. So just put it here. So let's say day 0 is that one. Like, so this is day 0. See the blood pressure. So let's put it in the variable box here. Then for the group, is it hiding now that is a group? No, there's a group option. Okay, so now for the category axis, it has already marked itself. So for the category axis, just select group and bring it to the category axis. Now when you select that, then you can click OK. Then no, before you click OK, let's go to options. Error bar. We want to display error bar, and I want the error bar to be standard deviation and not confidence interval. So just click on this standard deviation, leave the default setting, continue, and click on OK. So we have the same outcome. So that is just it already, like I was saying to us. Yeah, so I'm really not a fan of this because it's not really fine. I will not I must confess to us. Yes, it's not fine. Yeah, so you can always edit, copy, and take it to wherever you want to take it to. There are other software that help in constructing all these graphs. There are other graphs that help in constructing all these graphs. So we can always use. We keep learning. So we come to the end of it. Thank you for patience. Is there anything else that I've not talked about? You can construct the bar graph as well, pie chart, then pie chart as well. Just click on define. Let's say group want to see the pie chart. They are not fine. Define slices by, just bring it to this box. Click OK. And you see now we have it. It's not fine. You can format it, you can edit it, but it's still not fine. And that brings us to the end of it. Do it to buy our course on SPSS. That will do it to join the live class actually. And I also have another bonus for people that join the live class. I'm going to do like a 3 hours course, or now you can analyze your undergraduate projects, especially for nursing students. Like I've worked with a lot of nursing students. A lot, quite a good number of them. We have worked with them. So we can just maybe like a 3 hours course on how to analyze your project by yourself. It's very simple because this course is going to be like 30 hours. Now you don't really need to go through 30 hours course or like 30 hours because like 30 days estimated. So you don't really need to go finish the 30 days course before you can analyze your project by yourself. Within 3 hours, you will learn it and how you can incorporate AI tools. So thank you. I will come to the end of this and I will see you again.